Hello everyone, my name is Vaibhav Shukla. I am pursuing my BTech in Information Technology branch from Institute of Engineering and Technology, Lucknow. Currently I am in second year and my eYRC theme name is Nirikshak Bot and our team ID is NB1305. Now I would like to introduce you with my teammates. Thank you.
Hello, this is Shikhar Gupta and I am a student of Institute of Engineering and Technology Lucknow pursuing BTech from IT branch second year.
My name is Kushagra Shukla. I am pursuing my BTech from Computer Science and Engineering. My college name is Institute of Engineering and Technology Lucknow, and right now I am in second year.
Hello, this is Devansh Shrestha pursuing BTech in Electronics and Instrumentation Engineering from Institute of Engineering and Technology, Lucknow.
Now I will elaborate about the interesting aspects and the various challenges we faced throughout the task execution. We perch on the brink of industrial revolution that is really mesmerizing. To interact with all the latest technologies we need to make sure we proceed by all possible cross checks and safety measures to avoid any calamity. To operate a highly non-linear platform with full accuracy and identify different aspects of controls, this theme flourishingly teaches us to do that and boost the mass production with quality assurance and within the stipulated time frame. 2 degree of freedom ball balancing platform, which is used for laboratorial purposes and also in automation systems, allows us to understand the image processing control system and algorithmic implementation of mechanical designs and much more. Now I will describe the challenges we faced across the theme. So one by one, let's discuss it. So the first challenge was strenuous and cumbersome start. When we started setting up the software to run the theme and understand new concepts of image processing or simulation, it was literally too difficult to move on. However, we continued and automatically things became clear as crystal. The second challenge was encoding of maze and modeling of a 2 degree of freedom ball balancing platform. To read the maze and encode it was really too tiring as we were not getting any hint like how to process the image and convert it into a matrix. But after more than 20 unsuccessful attempts, we somehow did that, and modeling of platform took more than a week of continuous efforts as to connect the things and understand Cochlear SIM interface hierarchy dynamics was also grueling. However, by referring to web and online resources, things became more clear. Moreover, we did a lot of experiments and fun in Cochlear SIM to model our platform. Third challenge we faced was PID. PID was beyond all the concepts that we learned till now. I accept to start a new topic is difficult and filled us with fatigue. But to understand PID equation for the first time was totally and absolutely beyond our imagination. Those integrals and derivatives terms seems like it is meant for someone highly skilled professors, not for students. Moreover, perfect tuning also took lot of time. But yet, after so many unsuccessful attempts and experiments on our servo, we understood the PID equation. Also, instead of turning back, we kept on working with full zeal and enthusiasm. Thank you.
So we begin with entering our team ID path on workspace and then we click on proceed. So we will look how our simulation work, and this is the executable app which has been developed by eYantra. Now we will switch to the Cochlear Sim software, and this is our simulation software. So here we are having a scene and we are having different things. So one by one we will discuss about different aspects, the different things or the techniques which has been implemented to design this simulation that we are seeing right now onto the screen. So let's discuss about arena description that, and yes, we will go one by one slowly and gradually, and yes, after that we will have clear understanding how this simulation work and what are the things that actually that we are seeing right now. So let me describe about arena. So we are able to see that we are having four tables onto which some black color lines has been drawn, and yes, these black color lines are nothing but these are mirrors which has been drawn and they are acting as walls. So right now we are having different tables, or we can say four tables. In the center we are having table number 4, right to it we are having table number 3, left to it we are having table number 1, and in the front of it we are having table number 2. In the very same way, we are having 4 belts. Belt number 4 connects ball dispenser, orange color ball dispenser, to table number 4, and belt 2 connects table 4 to table 2. Table 4 to table 3 has been connected by belt number 3, and belt number 1 connects table 4 to table 1. Now, except table 4, all tables, and these tables are nothing but ball balancing platform. So I will be using word tables for now. So we are able to see that we are having 3 collection box onto which balls are continuously deposited as per instruction of JSON file, which is being read in Python script. So we are able to see that we are having 3 collection box assigned to table number 1, table number 2, table number 3. So let me tell the name of that. For table number 1, in front of it we are having collection box number 2, and to the left we are having collection box number 1, and to the right of table number 1 we are having collection box number 3. In the very same way, for table number 2, in the front of it we are having collection box number 2, to the right we are having collection box number 3, and to the left we are having collection box number 1. And for the table number 4, we are having collection box number 2 in the front of it, and collection box number 1 to the left of it, and collection box number 3 to the right of it. And now let's discuss about camera that we are having in this simulation. Actually, we are using vision sensor that works as camera and helps in image processing. So on the belt number 4, we are having vision sensor named 5, and this helps to detect ball color and its collection box by comparing it with JSON file in Python. And then we are having 4 vision sensor assigned to the top of every table, and this actually helps to detect ball position and used for the image processing. Now we will see how these measures are drawn. So with the help of Mage images, we are using .png extension Mage images. They are read, they are encoded in the form of 2D matrix, and then the data is transferred to the Lua script, which is being used in this CopleySim simulation software. And after that, using encoding and decoding technique, we are able to draw the walls of the various tables. Now, a very important thing, how this traversal is actually taking place. So this is done with the help of servo motor, which is acting as actuator in our case. Now, for every table, either it is table 1, 2, 3 or 4, doesn't matter, we are having 2 motors assigned to it in X and Y direction, and they are servo motors which have rotation freedom of 180 degree. So these servo motors are actually working as actuator, and with the help of PID equation, we are actually controlling it. What happens that the 2 motors controls the ball motion in X and Y direction independently, and yes, we are having highly non-linear motion, but with the help of PID equation and after perfect tuning, we are able to successfully drop the ball to the right collection box. Now, discussing about path strategy, I mean how the ball is able to search, or how this blue colored path has been drawn, which we are able to see right now in our screen. So this path is actually drawn with the help of obviously different APIs, but how this search algorithm works, so this is nothing but BFS technique which has been used or implemented on it. We are considering each cell as a node of a graph, and then we are making a graph by connecting them, and using BFS traversal technique from one node to another, we are able to detect the right path. So this was all about the description part. Now we are able to see that a ball has been dropped, and it has been dropped onto the table number 2, and we will wait for that unless it is dropped to the its designated collection box, that is collection box number 1 of table number 2. So we will wait, and for the next case I will discuss like how this actually the ball from the other journey of ball, each journey of ball, how it is done. By the time we can see that we are having this ball dispenser, and yes, it is dropping the ball at an regular interval of 80 simulation seconds. So as soon as the ball dispenser reaches its original position, I mean the zero count position, the paths are deleted so that for the next path, so that for the next case the path can be successfully drawn onto the table. And we see that right now that next ball is coming, which is blue colored ball, and slowly and gradually it is coming, and now we see that ball will be dropped on the belt number 4, and top of it we are having vision sensor 5, and this will help in the detection of the color as well as its collection box. Now collection box is detected with the help of JSON file by comparing it with its color and order. So the ball, blue colored ball is going to pass that belt, and we see that on the screen T3CB1 has been detected. That means that ball has to be transferred from table number 4 to table number 3, and right now we are able to see that as soon as ball drops on the table number 4, a blue colored path has been again drawn, and this is drawn with the help of various remote APIs, techniques, graph techniques, and strategies that we have used in our theme. So the ball is passing from the table 4, and yes, it will be dropped onto the belt number 3, and it has been dropped successfully. Now the ball will drop on the table number 3, and it has to reach, or in other words, it has to be deposited in the collection box 1. So accordingly we can see that path, a blue colored path has been drawn on that, and after that it will be dropped in the collection box number 1 of table 3. So we are able to see right now that we have successfully deposited 3 balls, one blue colored, one red, one green colored, and yes, this is the second blue colored ball that is being dropped, and yes, it has been dropped now. Now again we wait for the next ball. Right now in our scene we are having 5 balls. In this way we can have more balls, it doesn't matter, but the main thing is about accuracy and the collision factor and the time factor. So we are just here we have been provided with 5 balls only. So this is the last ball that we are having, which is red in color. So again, as soon as it will pass the belt number 4 atop the camera or the vision sensor 5, which is working as a camera on that, it will detect it, then send the data, and with the help of Python script image processing, we are using OpenCV library here. So with the help of that we will detect its color, and then we will compare it with JSON file, and after that the collection box will be detected. So we wait for that, and yes, we see that ball is going to be dropped on belt number 4, and we see that we wait for it. So yes, the ball has been dropped, and right now we are able to see on the screen red T3CB1 has been printed. Once again, the ball, the red define its color, T3CB1 defined the table onto which it has to be transferred, and CB1 described the collection box. So T3 is the table number 3. So we can see that the blue colored path from table number 4 to the table number 3 has been drawn, and as soon as it reaches the carving point of table number 4, we tilt the motor in the desired direction, and yes, that's why the ball has been dropped onto the belt number 3. And again with the same procedure, as soon as the ball drops onto the table number 3, our actuators, that is servo motor here, start working, and we are able to see that with the help of PID equation we are able to transfer the ball from to the desired collection box. And yes, we have considered different factors about proportional derivative integral gain, and we have done a lot of tuning to achieve this stable equilibrium of we have achieved this way, or the stable arrangement has been achieved by a lot of effort and tuning. So we see that the ball has been dropped in the collection box, in the right collection box, and our scene has been stopped. And then we switch to our grader app, and here we can see that status OK tested has been printed, which define that yes, all ball have been dropped successfully, and various scoring parameters have been given to us for ball 1, ball 2 to ball number 5. Okay, thank you.